Hello again. This is the second part of the video for Chapter 8, and we're going to start with a section on disinflation, credibility, and unemployment. So, disinflation, credibility, and unemployment. Okay. One of the big things we want to talk about is the costs of fighting inflation. And so that's what disinflation is. How do we get rid of inflation? And we'll see it depends upon credibility, how much you can believe what the Fed is saying. Okay, in 1979, the unemployment rate was equal to 5.8%. And that's probably close to the natural rate. And so we were probably pretty close to full employment at that time, given the structural change. The natural rate was probably close to 6% and other factors. But inflation was equal to 13%. So we have an economy that's running close to full employment, but a really high inflation rate. And even without the oil price shocks, which were part of this high inflation, the inflation rate probably would have been around 10%, according to the estimates the book talks about. And so we've got this high degree of inflation. The question was, how to decrease inflation without causing lots of unemployment? Because if you look at our Phillips Curve equation, and it's clear if that equation's true, if it actually describes the economy, that in order to bring inflation down, you're going to have to pay some cost in terms of higher unemployment. So remember that we derived this equation that was inflation was expected inflation minus alpha, some parameter, times the unemployment rate minus the natural rate. So you can write this. And this, we said, was pretty well modeled by last periods of inflation. We'll talk about how that might change. Expectations don't have to be formed this way, but for this time period we're talking about in the 70s, this was probably a pretty good model. People thought next year's inflation was going to be whatever last year's was, or this year's is whatever last year's was. And so this is a pretty good model. So you can write this as pi t minus pi t minus 1 is minus alpha times ut minus un. And we usually use a superscript, not a subscript. So this is the change in the inflation rate. So if we want the change in the inflation rate to be negative, if we want to bring inflation down, make this a negative number, this thing in parentheses, because there's a minus sign in front, has to be positive. That is, unemployment has to be bigger than the natural rate. And if you recall earlier, we estimated this parameter as equal to 0.55. And so pi t minus 1 is minus 0.55 times ut minus un. And this equation can give us one estimate of what the cost might be. And so let me just rewrite that. We can write our equation as pi t minus 1 over alpha is minus ut minus un. And this number is 0.55. So let me just write that as 0.55 instead of alpha. Okay? So suppose we want to reduce inflation, just to use round numbers. Suppose we want inflation to fall by 1%. How much would unemployment have to be above the natural rate? This is the time period here is a year. So we want this change in the inflation rate to be 1% for 1 year. So what you could do is say, okay, well, I want this to be 1%, which is the same as 0.01. So I want the difference over the from t minus 1 to t to be 0.01. If I divide that by 0.55, you'll get, and I want this to be negative, okay? You'll get that this, well, let me just, 0.1 over 0.55 is about 1.2%. And so what's going to happen here is in order to get, did I do that right? 1.8. I thought that looked wrong. 1.8%. So the point is to get inflation down by 1%, unemployment would have to be bigger than the natural rate by 1.8%. If you put 1.8 in here, that would equal 0.01 over 0.55. And you want it to be negative, so you got a negative sign in front because you want inflation to fall by 1%. And so this is the trade-off. Every 1% decrease in the inflation rate causes unemployment to go above the natural rate by 1.8%. That's pretty costly. So if you want to go from 10% to 4% inflation in 1 year, it would be quite a high, that would require that the unemployment rate be about 10% over the natural rate. So if this were 5%, that'd be 15%. You'd need unemployment to be 15% over the natural rate. And so in order to get a 6% reduction in inflation in a year, this implies you'd need to pay a cost of 10% inflation. Even if you distributed it over 5 years, say you want to go, these are all the examples from the book. Say you have a more modest goal, say just from 10% to 6%, and you do it over 5 years. You would still need U greater than UN by approximately, what is it, 2% per year. So 5 years of employment elevated by 2%. So according to this, it would be quite costly. So the conclusion that came out of these types of analyses was fighting inflation will be costly. So at the time, people did these kinds of analysis and boy, you're going to have to pay a big, big inflation cost. Now, there were others who argued against the idea that we would have to pay a really large cost. So let me go through the arguments that they make. And this is called the Lucas critique, after Robert Lucas, Nobel Prize winning economist, for a variety of contributions, this being one of them. The Lucas critique, in essence, says that when you change policies, when you change the rules of a game, when the government changes policies or somebody changes policy, historical relationships that are in the data may break down. Let me try to give you an example. Suppose that there's a street in town, Polk Street, that I used to take to work every day before they had all the speed stuff in there to slow people down. Now they've got things that they're trying to keep people from going as fast. But you could come down the hill on Polk Street, ended up going pretty fast, and you didn't worry about it too much because there was hardly ever any police there, so there was a lot of speeding on that road, and I have to plead guilty that I was one of them. In fact, I got a ticket for it one day. But anyway, if you were to then take and hide a camera or something and measure the number of camera speed, whatever you call them, something to gauge the speed, you'd say, oh, gee, if we put a policeman on this intersection, there's 100 cars speeding, in 4 hours. We could write 100 tickets. We're going to make this amount of money. So, gee, all we have to do is station a police car at this one intersection here, and we're going to write 100 tickets that morning. We're going to make a ton of money and stop a lot of people from speeding. And so they've looked at the historical data. And in the historical data, there's approximately, they've done this over a bunch of different days and took the average. And on average, there's about 100 people speeding. But then they actually put the policeman there, police person, and they don't end up writing 100 tickets. Maybe they write 15 or 20. Why is that? Well, people that go by My wife did this for me one time. She called me on the phone after she took that road and said, hey, there's a policeman there. Don't speed today. And so I didn't. And there's all these apps you can use and other sorts of things. You can call people on the phone. There's various ways you actually might see the policeman if they're not hidden well. And that's going to change their behavior. And so instead of having 100 people speeding that morning, maybe only 15 or 20 speed. And so once you instituted this new policy, people change their behaviors. They change their expectations about the chance of themselves getting a ticket. And that change in expectations changed their behavior. And so the historical expectation that it's only going to be very little chance that I'm going to get a ticket was changed by an expectation there's a pretty good chance. And that, of course, changed behavior. What Lucas and others were saying is that even though in the past this equation that we've been using to model expectations where we've set theta equal to 1, they're saying this might break down when you change the way in which inflation is generated. People might change their expectations. They're no longer going to believe this because the Fed's going to behave very differently. We'd gone through a long, long time period where the Fed hadn't really done much to fight inflation. It had promised to, and this is how it lost its credibility. It had said, year after year, this year we're going to fight inflation, and inflation got worse. This year we're going to fight inflation got worse. So the Fed had no credibility, and in that kind of environment, maybe this sort of expectation formation mechanism makes sense. But once the Fed gets serious about fighting inflation, then maybe we're going to change the way in which we form our expectations, particularly if the Fed has credibility. And so they were saying the following, that the actual equation is pi t minus pi te equals minus alpha times ut minus un. We have been putting pi t minus 1 there, but they're saying, no, that's wrong. These expectations will be formed differently if the Fed behaves differently, just like your expectations of getting a ticket will be formed differently if the police behave differently, if the policymakers behave differently. And so well, if the Fed has credibility, if what they say is believed, if they say, okay, we're going to lower inflation from 10 to 4, then expectations will also go from 10 to 4. People will instantly believe exactly what we say. In that kind of environment, you're not going to get any change in unemployment at all. The cost of fighting unemployment would be 0, because we start off with 10. Say we were at full employment, 10 minus 10. The actual and the expected is minus alpha times ut minus un, where the only way this could be true, this side's 0, this side has to be 0. So what this tells us is that 0 is ut minus un, so it must be that ut equals un, that we're at the natural rate. So just like we said, we started at full employment in the 60s. And then when we fought inflation, so say that they actually bring inflation down to 4%. Well, if this number changes to 4, but this number doesn't change because it's based on last period, which was 10% like we were using before, then you're going to get a 6% change, well, 6 times alpha change. That's how we got that 10% change in the unemployment rate. But if at the same time the inflation goes from 10 and expectations go from 10 down to 4, both fall to 4. So when this goes from 10 to 4, expectations change immediately. Then again, we're going to get that ut equals un. There's going to be no cost of fighting inflation at all. And we can show this later with a Phillips curve. I'll show this later graphically as well to help drive this point home. And so this rational expectations school, these people who believe that expectations change quickly, and so all the Fed has to do is tell us what we're going to do, and if it's believed and there's no fighting inflation at all, then unemployment's not going to be, fighting inflation is not going to be very costly. Let me make sure you see this. So we start off with, so remember the equation is pi t minus pi te, the expected inflation rate, is minus alpha times ut minus un. And alpha is 0.55 for us, so that's not really that important here. So if we start with at full employment, where our expectations, so inflation's been 10% for several years, so expected inflation is 10%. People have figured that out. Then in this case, it must be that ut equals un, that we're at the natural rate. And that's where we started in 1979. We said unemployment was 5.8%, which was about equal to the natural rate. Now, what we're going to do is bring the inflation down to 4%. And there's two possibilities. One is expectations don't change. This is the case where the expected inflation rate is pi t minus 1, which is 10%. It was 10% yesterday. Today we're going to change this to 4. So now we're going to get 4 minus 10. The actual is today, it was yesterday it was 10, but today it becomes 4 because they reduced it. But our expectation is still based on yesterday. Then you're going to get minus alpha times ut minus un. So in this case, ut minus un will be 4 minus 10 over minus alpha, or 6 over alpha. And if alpha is 0.55, this is how we got, that's that 10% that we got before. So you'd get a 10% increase in the unemployment rate if the expectations were formed this way. Now the second possibility is that expectations do change. And they change perfectly, exactly equal to the actual inflation rate. So in that case, what you get is 4 minus 4 is minus alpha times ut minus un. And here you get that ut equals un still, just like where we started. And so in this case, there's no cost of fighting inflation. And so if those expectations move as soon as the Fed announces, and the Fed says, we're going to lower inflation from 10% to 4%, people believe that. Their expectations change immediately or within the year. You're not going to get much of a cost, and this zero cost in the perfect case of fighting inflation. And so it really depends upon how quickly those inflation expectations respond to the Fed's announcement. That in turn is going to depend upon how credible the Fed is. If what the Fed has said in the past has always come true, then it's going to be credible. People are probably going to change their expectations relatively quickly because the Fed can be believed. It's shown it can be believed by its past behavior. But if, as actually happened, people hear the Fed saying, we're going to fight inflation, and it keeps going up, and people, what? You said you were going to fight it, and it didn't happen? I don't believe anything you say. In that case, you're going to get it's going to be quite costly because expectations won't change until you actually show them that you're serious this time, that this time really is different. And so the prediction is if the Fed had no credibility, and it really didn't, then the prediction is that you would get a quite costly, in terms of unemployment, effect from fighting inflation. So who was right? Those who said little cost because the Fed was credible and expectations would change quickly, or those who said there would be a large cost because inflation was based upon the past. People weren't going to believe it's based on the past, what they've seen. They're not going to believe it until they actually see it. Well, there was no credibility miracle. In September 79, Paul Volcker began increasing the interest rate to fight inflation. That's going to cause a slower economy, and the slower economy will cause inflation to go down. So what actually happened? So I'm going to have a big table here, a bunch of different years, 79, through 85, 80, 81, 82, 83, 84, 85. So that's the top. And then we want to look at the unemployment rate, the CPI. Remember, there's different price index. This is CPI inflation, and GDP growth. And so let me just put that on here. And so the unemployment rate was 5.8%. As we said, it was near full employment. And then it goes up to 7.1, 7.6, 9.7, 9.6. Then it falls a bit, 7.5, 7.2. This is all in your book. This was 13.3%. That's that 13% we cited when we started today. Then it went to 12.5. This is where they start fighting inflation, and it works. 12.5, 8.9, 3.8, 3.8, 3.9, 3.8. So they get it down to around 4%. That's where that 4% we've been using came from. And 2.5, this is GDP growth, minus 0.05. Kind of missed. Minus 0.05. Let me just keep these separate. Um, 1.8 minus 2.2, 3.9, 6.2, 3.2. Okay, so what's the point of all these numbers? Hopefully you can see them. I might step off camera here for a second to make sure you can see everything. So again, we start, let's put the unemployment line. We start fighting inflation right here, and you can see inflation falls, and it's about 81, 82 is when it finally stabilizes. What happens to unemployment? Well, we start near full employment. It really goes up. And then once inflation finally stabilizes, unemployment begins going down. But it's not back yet. It's going to take a while for it to get back to full employment. Same thing with GDP growth. It's pretty strong. They start fighting inflation, it falls. Then once inflation stabilizes, GDP growth gets strong again. So what we're seeing here is that it was, in fact, quite costly to fight inflation. That the Fed, it looks like, did not have credibility. Let me show you how to do this same story with a Phillips curve. So let me start before 79. Let me go back to the 60s. Remember, this is unemployment versus inflation. That's what the Phillips curve is. And I'm going to start off before 79 when we had all these troubles. I'm going to start off back in the 60s when the expectations of inflation were 0. So this is the expected inflation rate. Let me put 0 right here. Here's 0. Now when expectations are correct, remember this is the actual inflation rate is 0. So we're expecting 0, we're getting 0. When that happens, you're at the natural rate. And this is that original Phillips curve they estimated in 1960 for the US and in 58 for Britain. Though in Britain they use percentage changes in wages. You can do it for inflation there too. You get something similar. And then what happened in the 60s is they start trying to push unemployment below the natural rate because they want a strong economy. Let me just call that U for unemployment so I don't mix it up with UN. The natural rate, which ought to be a superscript. Sorry about that. So they start trying to push the unemployment rate, down to 3.9%, and they're willing to accept some inflation. And what happens is they get the inflation they wanted, but as Milton Friedman predicted, and as we saw in our model, this curve shifts whenever expectation shifts. So once they got here, people said, oh, we've been expecting 0 inflation year after year, demanding a certain wage increase. We've been wrong. There's higher inflation. Shoot, our real wages are lower than we thought year after year. We'd better change our expectations and get this right, or they're going to keep fooling us. and they're going to keep being able to pay us less in real terms than we've actually bargained for. And so people changed their expectations. When that happened, the Phillips curve shifted. So here's the Phillips curve. Let me call this pi 1. For expected inflation equals pi 1. If you're correct, you're at the natural rate. What policymakers did was say, oh no, we just didn't do enough policy. And so they increased the money supply again to try to stimulate the economy, giving us an even higher inflation rate, something like 13%. And for a while it worked, but then expectations changed. And we end up, pi e equals pi 2, 13%. We end up at this natural rate of 5.8%, though that might have varied a little over this time period, but it was 5.8% at the end of the 70s, and an inflation rate of 13%. So we start off at this point. So we got there by trying to push the economy below the natural rate of unemployment. Now why do they do that? Well, the reason is simple. They really misread what the natural rate was. It had been 4% for a long time throughout the 1960s. As we get into the 70s, we get a baby boom. We get women entering the labor force for the first time. We get a lot of structural change. And with the baby boom, a lot of first-time workers, a lot of teens hitting the labor market, a lot of women entering. First-time workers change jobs a lot. There's a lot of what we call frictional unemployment. Oh, I want to be an accountant. I really think you go to school, you become an accountant, you go out and try it in the real world for a year or two, you find out you hate it, and you go off and you do something else. And it takes a while to sort of settle into a job and stay there. So you see a lot of transitory, a lot of frictional unemployment in those among first-time workers as they figure out what they want to do. And so that raised the natural rate of unemployment above 4%. The Fed targeted 4% thinking it was full employment, when in fact the natural rate was much higher than that. So they tried to push the economy to what they thought was full employment. Then the expectations adjusted. They tried it again and adjusted. And they find themselves sitting here realizing, oh, we'd gotten the natural rate wrong, and we're stuck with this high inflation rate. And the question was how to get rid of it at this point. So let's start there at the last point, because I don't want the graph to get too cluttered. So let's begin again with unemployment on this axis and inflation on this axis. And we're sitting here at a point with a Phillips curve, pi e equals pi 2. We're at the natural rate, un, and an inflation rate of pi 2, and you can think of this as 5.8, and this is 13.3 if you want to be even more precise. And the Fed says, okay, we want to get rid of this inflation. We want to bring it down to pi 1 equals 4. And this was 13. What's going to happen? Well, if the Lucas critique people were correct, all the Fed had to do was say, we're going to lower inflation from pi 2 to pi 1. Expectations adjust immediately. Well, let's go through the case where they don't adjust quickly to begin with. And I'm going to move this up just a little bit because of the way I drew my graph. So here's pi 1, and that's 4%. So we want to lower it to 4%, to right here. So if the Fed announces pi 2 to pi 1, 13 to 4, and people don't believe it because the Fed has said this before and it's never been true, then what's going to happen is these expectations are not going to change. People are still going to expect 13, because last year it was 13 and the Fed said they were going to lower it. It was 13 again. Why should it be any different this time? So if the Fed actually lowers it to 4% with those expectations, you're going to get a great big increase in the unemployment rate. You're going to pay a huge cost of fighting inflation. That's exactly what we saw in the data. It could go up to 9% or so. Okay. On the other hand, so you go from A to B, then over time people say, oh, this time the Fed was serious. This time the Fed meant what it said. I can see it. Inflation's 4%. Okay, I should change my expectations. And when they change their expectations to pi 1, you move from point B to point C. So you pay this huge cost of fighting inflation. You go A, B, C. What the Lucas critique people were saying was you don't have to pay that cost if the Fed's credible. Because if you say, I'm going to lower inflation from pi 2 to pi 1, right as you do it, expectations change, and you just go from A to C. So the Lucas critique people thought you could go directly from A to C, and you would skip B. You don't have to go out. You know, you might take a path more like that. There might be a little cost because of various reasons, but you're not going to take this big, long, high unemployment route to get this lower inflation. Well, what actually happened is it looked a lot more like ABC than a direct route from A to C. And so it looks like expectations were, in fact, based upon not anticipating the Fed would actually do what it was going to say. This is why these days the Fed is so concerned about keeping its credibility. Because if it has credibility, it can announce, I'm going to change the inflation rate from pi 2 to pi 1. It can lower inflation without paying a great big unemployment cost. But if it can't control people's expectations, if people don't believe what the Fed is saying, then it could be quite costly. All right. Good enough for that section, I hope. Let's go on to the next one. So we're going to look at indexation. What happens if there's indexation in the economy? What is that? When you have a lot of inflation in your economy, particularly if there's high inflation, wages often get indexed to inflation, to the actual inflation rate. So as inflation goes up, and you can see it in the data, wages change right along with it, so that there's no change in the real wage, W over P. So as this goes up right along with it. It's indexed. We see indexation in things like Social Security payments. A variable interest rate loan is really an index loan because the interest rate changes as inflation changes. And so there's ways to index the economy against inflation. What we're going to see is when there is indexation, you get a stronger response of inflation to a change in the unemployment rate. So let's try to see how that happens. This is a little bit more algebraic than the things we've done, but it's not too bad, I don't think. So let me give myself a little more room here. We're almost done with this chapter. This section and one more, and we'll be there. So let's have two types of wage contracts. One, a proportion, lambda, and it's between 0 and 1. It's a fraction. A fraction, a proportion lambda, these could be equal, by the way, is indexed of wage contracts. Is indexed. I guess this is singular. Sounds weird. Are indexed. I think that should be is, though, technically. Are indexed. So the wage moves 1 to 1 with the price level. So that W over P is unchanged. This is W here, the wage. 2, a proportion 1 minus lambda are not indexed. And these are set based upon expected inflation. So you could have two types of wage contracts. One that during the year or during a 5-year period or however you want to break up the time, let's just say a year. During the year, as new inflation statistics come out every month, wages are adjusted. So they're indexed. And if you had 100% inflation a year, like some countries have had in the past, that's something you'd want to do. You'd want those wages to change often and fast in response to new news about what the inflation rate is. Another gets set at the beginning of the year, and they don't change for the whole year, and it's based upon the expected inflation rate for that year. So you meet in January 1 with the boss, you negotiate, you bargain a wage, and it's based on the expectation of the increase in the price level. Under that type of a scheme, without going through the details, the Phillips curve becomes the following. It'll be that inflation equals lambda pi t plus 1 minus lambda pi t e minus alpha times ut minus un. So instead of just having pi te here like we had before, this is essentially the expectation. These people are the indexed ones. This is essentially their expectation because it's exactly equal to inflation. So it's just lambda pi t. These people have to base it on their expectation at the beginning of the period. But anyway, this is how it works. Now let's assume that the expected inflation rate is pi t minus 1 as before. Then you'll have that inflation equals lambda pi t plus 1 minus lambda pi t minus 1 minus alpha times ut minus un. So under indexation, this is the Phillips curve, and lambda is the degree of indexation. When lambda equals 0, it's the same as before. You get that pi t is pi t minus 1 minus alpha times ut minus un. So this is what happens when there's no indexation at all. And that's the Phillips curve that we've been using up until this point, except for the Lucas critique one. When lambda is greater than 0, so let me just keep this, we're going to use this equation here. So next is when lambda is greater than 0, what you get is that pi t minus pi t minus 1. Again, this is the change in the inflation rate is minus alpha over 1 minus lambda times ut minus un. So that's under indexation. Now, since lambda is between 0 and 1, alpha over 1 minus lambda is bigger than just alpha. This is a bigger number. So what that means is if this goes up by 1%, the change in inflation will be larger than before. So what that tells us is that as the proportion that are indexed, the degree of indexation goes up, you get a bigger and bigger response of inflation to changes in the unemployment rate. Why would that be? So why? What's the intuition? Why do you get a bigger response of inflation to unemployment? So why? Without indexation, unemployment going up causes wages to go down, and that drives price down. That is, inflation goes down. Have I shown you this before? In log terms, PT minus 1 is inflation at time t. PT minus 1 is fixed, so if PT goes down, inflation has to go down. So P going down is the same as inflation going down. If the current price is lower, inflation is lower. So, without indexation, that's the end of the story. This is that alpha parameter. Unemployment goes up. Remember that without indexation, you just have that the change in the inflation rate is minus alpha times UT minus UN. When this goes up by 1%, this goes down by alpha. Inflation goes down by alpha. With indexation, what happens? Then the story's different. When the price goes, when unemployment goes up, wages go down, same story so far, and prices go down. But then the story, that is, inflation goes down. But that's the end of the story without indexation. But now wages are indexed to prices. So when prices go down, that causes wages to go down. Not as much as this time, because there's a fraction involved. It's eventually going to converge. But wages go down again, and that causes prices to go down again. So inflation goes down even more, and that causes wages to go down even more. Again, this might be, like a half, a quarter, an eighth. You get smaller and smaller. Prices go down again, and inflation goes down again, etc. But you get a bigger response because of the feedback between prices and wages that doesn't exist without indexation. So with indexation, whenever inflation changes, wages change. That changes inflation again. That changes wages again, and you get this snowballing process that gives you a bigger overall change. Okay, one last topic. Deflation and the Phillips Curve relationship. During the Great Recession, and the same thing happens in the Depression in the 1930s. Let me just recall that pi t minus pi t minus 1 is minus alpha times ut minus un. During the Great Recession, unemployment went up a lot to near 10%. Above the natural rate, a big change. A change of that magnitude should have caused a great big fall in the inflation rate year after year after year until eventually inflation should have fallen below zero, which is what we mean by deflation. So and that didn't happen. Inflation did fall. The Fed's target's 2%. It did fall, and for a while it looked like it might go negative, but it never did. And sort of stopped and then sort of stabilized somewhere below the Fed's target, but it never became negative. It didn't keep falling. There was no spiraling deflation like a lot of people feared. So for some reason, this equation broke down. The high unemployment rate, alpha, seemed to change somehow, to zero. It didn't cause, after a while, it didn't cause, initially inflation came down, and then suddenly the high unemployment just didn't seem to have any effect on inflation at all. Why is that? Well, the reason we think that happened during the Great Recession, that it broke down, is because of downward wage rigidity. People don't mind at all if you raise their wages, but they're strongly resistant to cuts in wages. In fact, it'd be counterproductive. If you cut people's wages, you think you're saving money, they might just not work as hard and their productivity might fall even more. So whatever you saved by cutting wages is more than offset by declining productivity, declining morale, and all those sorts of things. And so for a variety of reasons, wages don't like to fall. During the Great Recession, the way they tended to fall was they laid some people off and then hire new people at lower wages, but even that seemed to be relatively limited. If wages have this floor on them where they won't fall, that's going to stop inflation from falling. So the existence of these nominal wage rigidities is probably responsible for the fact that we didn't see exactly what the Phillips Curve predicted during the Great Recession. That's it for Chapter 8. Thanks. See you next time.